So here we have the final question on our trigonometry quiz for junior cert, and this is going to be a bit of a harder question, so don't worry if you had to come just to double check your answer, because this is a harder one. But we're basically told that a kite is flying on a string of length 60 meters, and the string makes an angle of 35 degrees with the horizontal or the ground, and the string is tied to the top of a 1.5 meter post. And so what I always do straight away is just draw a diagram. That's always going to be my process, and I think it does help. So we draw a little post here, which is going to be 1.5 meters tall, and we can basically draw our kite, which is going to be on a string. So we can draw the string up here, which is going to be 60, and don't worry too much that it isn't going to look really like the exact visually accurate side lengths, because it's just more of an idea to get an idea of the actual nature of the problem. So we have this 60 meter string, and then the kite we can just draw up here as a little sort of diamond shape is going to be on the end of the string. And then our last key piece of information is going to be that the angle in here, so the angle kind of that the kite makes with the horizontal, is going to be 35 degrees. So we're given that in the question. And our goal here, which I'm just going to use to write that down in red, so our goal here is going to be to find the overall height of the kite above the ground. And so we can see here straight away that h is going to be made up of two things. It's going to be made up of the 1.5 meter post on the bottom, so that's going to be kind of the first segment of the height, and the second segment of the height we're just going to call x, which is going to be what we get from using trigonometry to find the length of the height above the horizontal for the kite. So hopefully this is making sense. Again, this is more of a challenging one. This is kind of the kind of one you'd see in your exam, and you might even be given a diagram, but it is good practice to always be able to create diagrams for yourself. And so you can see here, in order to find the height that we're looking for, we have our 1.5, but we need to find the value of x. And so our next job is going to be to figure out what information we have and what information we need using our trig ratios. So our rule for remembering the trig ratios, or the rule I always used, is going to be SOHCAHTOA, and this is basically just a way of writing all the letters down for sine, cos and tan. And if you need a bit more practice with this, there is going to be easier questions in the quiz just in the first few that we kind of explain SOHCAHTOA a bit more in depth. But what we basically need to do now is just actually label our sides that we're given, or the side that we're looking for. So the height of the kite above the post is going to be equal to the opposite in this triangle. So we can say that h is going to be the opposite. And then we know that the actual kite is on a string of length 60 meters, which is going to be our hypotenuse. So that's going to be basically the longest side here. And then our right angle is going to be down here, just connecting the horizontal and the vertical. And so we have h, and we're looking for O, and we also have this angle of 35 degrees. And so we just look at our trig ratio, SOHCAHTOA, and we see that sine is going to be opposite of our hypotenuse, so that's what we're going to be using here. So we can set up our equation now, and it's going to be sine 35 is equal to the opposite, which we know is h, which is our unknown, over the hypotenuse, which is 60. So what this means is that h is going to be equal to 60 times sine of 35 degrees. So that's what it boils down to here. But actually, I'm just realizing there's a small mistake with the labeling. So the h isn't actually the opposite. It's going to be that x is the opposite. So x is going to be our opposite. So I just changed our h's there to x's. Basically, the reason for this is because we need to add on x at the end to find the actual overall height, but just by adding 1.5. So that's a small thing that actually we need to watch out for here. And so basically we plug in this value of 60 sine 35 into our calculator, and we get that x, which is the first segment of our height, is going to be equal to 34.41 meters. So that's going to be basically the first fraction of our height. And then, as we said, to find the actual final answer for h, we can simply add 1.5 to this value, and that is going to give us a value of 35.91. And so the nearest meter is going to be 36 meters. So that's the height of our kite above the ground. So that's going to be basically it for part A. So for part B, we have something a bit different. So we're told that the kite drifts, so the angle drops to 28 degrees, but the string length stays 60 meters. And so what I'm going to do is I'm just going to draw a new diagram quickly. So we have the same length of the post, but now our angle has basically reduced down to 28. Our string is still 60 meters, and so we have all our information in the question now drawn in, and we're basically looking for the new value of h. And so the good thing about this is that we're using the exact same trig ratio. So we can simply plug in sine of 28 is equal to x, which is our new kind of height in our triangle. We're going to be adding on that 1.5 at the end once again. So the sine 28 is going to be x over 60. And so we can simply do it the exact same way as last time now with the 28 degrees instead of the 35 degrees. We're going to get that x is going to be equal to 60 times sine 28. And so once again, just repeating the exact same process now for a new angle, and our final answer here is going to be 28.17 meters. And so we're almost there now. So we found x, and just like we did in part A, we're going to have to find h by taking this 28.17 and adding on our 1.5, which was a length of the little post that the kite is tied to, so we need to add that in. So this is going to bring up our overall height to a value of 29.67 meters. But our very last step in this question, if we go back up to how it's phrased, is to find how much the height has changed. So basically our height is reduced, which makes sense because the kite has basically fallen down, so the angle has reduced as well. But what we basically need to do now is we're going to be using our values of 35.91 and 29.67 to find the overall reduction in the height. And you'll notice I'm using the values before they're rounded off, so we just don't miss out on anything. I think if you rounded them off, it would probably be okay, because the goal here is to round them off to the nearest meter at the very end. But we can basically just do them before rounding them off to find the most accurate change in height first. And so that's going to be 35.91 minus 29.67. And this is going to give us a value of 6.24. And so when we round this off, we're going to get that the overall change in the height, it's basically reduced by 6 meters. So that is our final answer for part B, and that's going to be it for this question.